I think I pronounced it that right. Correct me if I'm wrong.
You did actually for a general audience. Where I come from in the west of Ireland, it would be Keneally.
Keneally.
If you say that to most people, it'll get spelled 17 different ways. So
yeah, probably with two O's in it.
Yeah, or EALLY or two E's LY or whatever. So Connolly is what we use when we need to keep things simple.
So on that note, I'm learning something. See, folks, you learn something every single day. Oh, you got to respect the name that you were given, right? Or the name that you inherited in some cases, right? I have no idea where I came from. I'm a mutt. I came from some island somewhere and worked my way across the Atlantic in a thought. So here with Julie Keneally. There we go.
Shout out.
Yeah, absolutely. Go west of Ireland. I'm a Mayo guy myself. I have the jersey in the other room. So there we go. And we're here to talk about a couple of things. Well, number one, about Julie herself, but community, trust, and then some of the cool shit that she's involved in. And yes, I did say that word, and we will continue to use those words because this is a conversation. This is not a church. So that being said, we'll start there. So Julie, give us a little bit of background about yourself and how you managed to get into this mess.
Yeah, so I suppose I started in the research community. Yeah, my very first job was in a telecoms research company called Broadcom when I was straight out of college. And that was basically a paid internship in telecoms research in a very probably unusual institution. At the time, it was formed by Trinity College Dublin, Ericsson and Telecom Éireann, so the incumbent public telecoms provider at the time. And the research aspect was a lot of EU projects, some stuff that Ericsson had, coming out to market, but mostly, European projects in the telecom space. So talk about landing on your feet out of college when there weren't many jobs really at the time. Yeah. It was just a joy to work there. We got to travel the world. At one point, I got to spend a couple of weeks in Geneva attending the ITU standards meetings. Wow. It's the sort of stuff you pinch yourself when you think about it, that managed to be on the 13th floor of the ITU tower in Geneva. Wow. Amazing stuff from a girl who grew up in the fields of Roscommon. So very exciting. And probably 5 years in Broadcom led me to the market unit of Ericsson. So some research we had been doing on standards for a new optic fiber transmission system that Ericsson were developing. Came to market in Ireland. We actually tendered for it. I was probably weeks away from my honeymoon at the time, spending 14-hour days in the office writing manual upon manual about what this product could do for the Telecom Éireann backhaul network at the time. It was really, really cool stuff. This was probably 8 times the capacity of a standard fiber cable. So it was, it was really high spec stuff. And we were installing it in the international landing station at Kilmore Quay and backhauling to Dublin to one of the biggest exchange buildings that Telecom Éireann ran at the time. And it was all very cool stuff. So when we started my very first research project in Broadcom was a 2 megabit wide area network between the 3 institutions. 2 megabit wide area network. Kids have it in their back pocket these days. It was mental stuff. Yeah, we could count the number of digits of all the bits we could transport across this wide area network. And nowadays it's like multiple petaflops going on around the place. So when I think of it, I don't even really want to say how many years ago, but many years ago, and it's just been incredible. So after probably 10 years in Ericsson then, peddling our new technology and bringing it into actual practical use was really, really exciting. And then supporting other markets in rolling it out in other operators around Europe. And then probably, say 10 years into the market unit work, I had my 3rd child and decided that, this was going to be too much of a juggle. So I stepped out of the workforce for 10 years to be at home with my own 3 little chicks. And
the hardest job in the world.
What's that?
It's the hardest job in the world.
It certainly is. Yeah.
Absolutely. Fiber's one thing. Kids are a complete different animal. So
it wasn't an easy transition, I have to say. I found it quite lonely in the beginning because all my adult life I had been in the workforce. So suddenly finding myself at the school gate with buggies and nappies hanging out of me and doing runarounds between different schools, it was quite a big change. But you know, those years go by so quickly, and now the kids are independent, wonderful young adults in their own right. So don't regret a minute of that. No, not a minute of it. But in the 10 years that I was out, you do kind of lose a sense of who am I in a work kind of environment. So coming back into the workforce in 2016 was very exciting and also a bit terrifying. So shout out to Adapt and all the wonderful people who work there who kind of took me under their wing and gave me a chance, I suppose. And my current boss, who I've been with since that time, a lovely French professor in the School of Computing in Trinity College, has also been a huge advocate for me working for her in her area. And that's probably the whistle stop tour of where I am today. So we started together as on a project with AIR. So funny how these things come full circle. When I started working first, it was Telecom Éireann. And when I came back to the workforce in 2016, the project I ended up working on was with AIR, which had since been privatized and so on. But so having had some telecoms background, joining a team on an industrial collaboration through the Adapt Centre, it just made a lot of sense, made me feel very comfortable actually that I had some background in this area, that's something I could contribute from my own past as well as, learning. I should say, actually, I did my master's in AI before I left college. So that was another full circle when I came back to the workforce to find that AI was suddenly, backpropagation networks didn't die, even though the one I had when I did my master's in meaning representation, and the neural net came on a dongle that you put into the side of the computer. It was a tiny little thing. I don't even know where I got it from. I must look it up and see where it came from. But having seen then the transition through the years to the massive supercomputers that are around now and the oodles of data that you can use to train all these networks, it's kind of reassuring to think that something we were doing kind of way back when has really found its feet, for want of a better word, in so many different areas of life as we know it in the 21st century. So so that was kind of another one of those serendipity things, thinking, okay, this was meant to be because I know this stuff. So we started on the project with AIR. Roseanne and her researchers are computer vision experts, as well as statisticians, as well as physics. It would blow your mind how much these people know and how much they've trained in over the years. And they applied their super brains to this project that we were doing with AIR, which was around image processing and detecting objects in imagery, and got a good result from that project, and also a hint as to other applications of the same technology in a wider kind of context, maybe commercially. So we started to investigate that. 2017, 2018, Enterprise Ireland came on board and said, do a feasibility study and see if there's a market there. And it seemed to turn up a bit of interest with various sectors, not just the telecoms operators, but things like autonomous driving and smart cities and environmental monitoring. So there's a huge history of satellite imagery and, the ultimate Earth selfie, looking back at ourselves from outer space. But there's not so much done in street level image processing. So looking at the world around us on ground level. And that was what we used. We used Google Street View imagery to analyze the road network to find where AIR's poles were, and then some very smart maths, which I could go into, but I probably wouldn't do it justice. Some very, very clever maths, which are historical techniques by all accounts, but with a modern twist, helped to give an accurate location to all of these poles. So yeah, so we started looking at the commercial potential. Probably we got some funding in December of last year, so almost a year ago now, but we had a little bit of time in the middle where COVID interrupted our plans and
Yeah, yeah.
recruitment was a little bit tricky and things like that. But we're up and running now. We have some really, really good guys on the team. And here's Adam going to take the dog out.
Hey, how's it going? Welcome, visitors.
This is live, Dave. This is live.
Absolutely. I mean,
Live
COVID's changed everything, man. You know, like I've always been impressed by that. So yeah,
we're not working from home. We're living at work, as the man says.
That's a very good way of looking at it. I've been doing the home work from home / travel thing for a decade now, and it so when all this kind of hit, it was kind of like not much has changed except for the isolation. That suddenly got a lot more different in grand scheme of stuff. So that is a lot to unpack, which I appreciate because there's lots of different threads in there that I want to pull apart and talk about. Let's go to the ostensible question, which is all about community. Because you mentioned a couple of different things. You stepped out of a community, right? Erickson, you stepped out of this kind of technological space and you became, for all intents and purposes, that mother driving 3 children and growing them and maturing them and providing, input into their character and their development, right? As we saw Adam step right through the door, a young man that he is. So these things are important. It's foundational, right? It's a different type of community. It's going from a work community, which I'm sure there was social overlap as well, to being, based at home, to then going back in. And like you said, you were welcomed by the Adapt Center folks and, really kind of, I won't say handheld, but, kind of gentle guidance and gentle bringing back into the fold, right? So community never left you in any of those particular circumstances, though the nature of it maybe changed a little bit or the presentation of it. So that long-winded statement of fact being what it is, what does community across all of your experience, what does it mean to you?
It's just people. Really, it's just people with a willingness to share what they have and what they know, and to include someone new and be part of, well, it's a team thing, isn't it? People want to feel that they have other people to lean on at times when things get tough, whether it's in work or it's at home when your kids are sick, or if you don't have the bumblebee outfit that they want when they're going for their
sounds like there's a story there too.
Yeah, I'm not good with crafts here. They've worn the same dress up outfits all their entire primary school education. But community, I suppose, a common purpose, willingness to share, a willingness to promote each other, which in the academic world, people are kind of shy about. They tend to live in their own little world and be very intensely driven in a certain area to the exclusion of, the kind of loose associations you might have if you're working and you're, on different projects and you're jumping around with things. So when in the research community, people are quite intense. It doesn't make them, any less good or decent, but they definitely have a focus that's more razor sharp in their particular area. And sometimes the social aspects of it are difficult for them then, so I think a good team with a mix of all the different people is a little community in itself, people who have the ability to see in others what they don't see in themselves. I think that has, it has potential to include aspects of people that really bring a lot more depth and a lot more willingness to explore. So when we started our project with AIR, we had people with different ideas who'd come from different backgrounds, but with a common goal, started to really gel. It takes a little while, everybody's getting to know each other and kind of seeing who they can trust, who they can trust with their ideas, who they can trust with their not quite fully formed ideas, but something they want to get out and see what other people think about it. It's really a wonderful thing. I enjoyed that project so much. Every week was a buzz to hear, what new ideas they had about how to do things. I mean, it would make your eyes water sometimes, the statistics and the modeling and,
Yeah.
but I said this to someone recently. I came from a secondary school education with past maths into a college of computer science degrees, people with honors physics. And I remember failing my first exam ever, actually, in
Yeah.
first year at the Christmas tests. And my tutor in college happened to be the head of the department. So I was pretty sure I was being kicked out, when he called me to his office to discuss the Christmas results. Like, yeah, I'm going home. They've found me out and I'm done for. But he just said to me, look, go to all the tutorials, get your friends to help you. And by some miracle, 4 years later, he walked out with a degree in computer science. Like, I loved computers. We had 2 computers, a very funky maths teacher in our west of Ireland secondary school convent managed to get 2 IBM computers that we played with at lunchtime. Yeah, and he was still talking about punch cards and things like that to us. So it was for a gadget girl, having a computer in the school was just like, this is amazing.
Yeah.
To play with it all day long and just. We weren't doing anything really. Just the idea of it was so cool. But yeah, so where did that come from? I don't know. Yeah,
So,
well, share ideas. Yeah.
And
So
to promote
the
others in that ideal. Yeah, absolutely.
Yeah.
I think it's fascinating.
Working now with people who are so proficient in maths terminology and just starting to understand the tiniest bit about modeling or functions, or, all those kind of things, made me really hunker for more information, more knowledge, want actually to encourage my own kids to be more curious about those things. And I've gone, oh, maths, which is, it has such a bad rap. But actually, once you see it in action, once you see what you can do with something that you can apply to a real world problem, it would blow your mind. It's absolutely nothing but awe for the people who, can take those really complex formulas and theories and all the rest and see how to use them in the real world. It's quite incredible. It's amazing. I just consider myself to be so blessed to have landed back in the middle of something that has so much potential. So
you're talking so eloquently about it. So I want to touch on it because we want to get to what you do and kind of that presentation. Not the presentation, you know what I mean? The explanation, like even more so. So you had mentioned a lot about, so you're going from this community, which is great. And you're coming in and, old skills are new again. Kind of everything is cyclical in this world that we deal with, especially in technology. Old is new, new is old. And it changes by the month, like when this is released, I'm sure there'll be even more advents in between now and whenever it ends up coming. When you came through Adapt, now you mentioned that there's a new product or project or even productization. You mentioned live view, that kind of street view of people don't take a lot of time to consider. We've seen the images of Google backpacks and with the cameras and Apple's doing the same thing, and there's a lot of really cool stuff around it. I used live view or used street view the other day to determine that an address that somebody had sent to me was actually in fact not existent. There's no building on that place. So it provides a lot of context and a lot of detail that a lot of times we miss. Early on in Elemental Collision, I talked to a gentleman named Donald Fallon, who runs a podcast called Three Castles Burning, which is really around Dublin's history. A lot of just the fundamentals, things that you walk by every single day that you wouldn't actually know or contextualize. The O'Reilly house that was just demolished down by the embassy. That was a thing that he goes, you don't understand the provenance of this place. You don't, we take for granted these things that are around us. And so you guys are putting a different kind of spin on everything that's around us. So can you tell us a little bit more about what, your project within Adapt is doing? And then we're going to wrap that into a nice little bow with trust, because you're dealing with data. So
yeah. So, imagery has, as they say, a picture is worth 1,000 words. There is so much in an image. And as a human being, what you see, you interpret with all the different experiences you've had through your life and all the knowledge you have about whatever you're looking at, right? Mm-hmm. For a computer to take an image and extract information, there's a lot of steps that have to happen, and you have to have a purpose. So what are you looking for in this scene? Mm-hmm. So what our system does is segment down the parts of the scene and creates a mask around something that we're interested in. So with the air project, we were interested in telegraph poles. So it segmented out everything else and just focused on through lots of training. So these are convolution neural networks.
Yeah,
Lots
of labels, lots of labels, lots of
data. Yeah. So public data sets augmented with examples of the actual poles that we wanted to find, and also augmented with negative examples. So things like ESB poles, which we weren't interested in, that are very similar to air poles.
Sure.
So you literally have to train the computer to the very specific thing that you're interested in the scene, right? And once you've done that, you know, for the purpose that we wanted it for, once it was trained and refined and segmenting the poles well, it can do this for ever and a day, accurately and reliably. Whereas if a human being had to sit and pick out a pole in every scene, eventually they'd get bored and they'd stop doing it properly. And it obviously would cost a lot more money because you have to sit there and pay that person to do it over and over again. So there's a lot of digitization going on. Lots of people now are moving all their records online, you know, straighten them out, put them into linked data sets or whatever. Telecoms operators, probably like most of the historic utility and agencies of state, have very poor records. That's just, you know, a feature of where they came from. Some of the poles were installed in, you know, 1920 or whenever the network was first established. So the location of that pole was written down as at the end of Canales Road on the left-hand side behind the field with the big rock. You know, nowadays you want it to be a GPS location so you can plug it into your mapping tool or your GIS platform, and it will open up the world and show you exactly where your pole is. And that's what operators need, especially now with COVID and everybody needing to be online. The need for telecoms coverage is growing exponentially. Everybody needs to be able to access all of their world via their device, their screen, whatever. So operators now have real incentive to speed up their operations, have their planning and design, you know, in the bag before they go to site and find out actually that pole isn't where we thought it was. It's now in so-and-so's garden and we have to go and get permission, and the engineers are, you know, that's a day wasted. So that's where our journey has taken us so far. We've trials with a couple of operators who have similar issues, want to make all of their records much more accurate, online, connected, you know, plugged into all the various planning tools they have, all the various GIS platform and visualization tools. And that's what our system can do. You know, once we've trained it on a particular object visible to the human eye in Google Street View imagery, we can literally run it for thousands and thousands of kilometers, you know, saving all of the time that it would take engineers to go to site and do that for them.
That's impressive.
So when you think about it, there's 100,000 kilometers of road in Ireland. There's 400,000 kilometers of road in the UK. There's, I think, something like can't quote it because I can't remember, a very, very large amount in the US, you know, all over the world. There's
a lot,
you know, a lot of infrastructure distributed over huge geographical areas that needs to be brought up to date in a digital record. And that's what our system could do. So that was where we started. And then we started looking at other things. So mapping in general is becoming huge. So there's a couple of very big players. There's Google, obviously. There's a company called Mapillary. They were a startup in Sweden about 7 or so years ago, recently bought by Facebook, which was a bit of a surprise. But they were crowdsourcing imagery. So they were basically asking all the mapping geeks in the world to upload their imagery to their site, and then allowing them to access other imagery, but kind of maintaining a crowdsourced ethos. So they were connecting to OpenStreetMap, which is another crowdsourced mapping platform. And so there's a whole vibe of that. There's the Google Street View imagery, which is a bit more professionally captured, but also a little bit less accessible in terms of licensing, and probably for all the reasons you mentioned. I mean, as a you know, a person living on a street, I can contact Google and say, take my property off your platform. I don't want it to be visible. And so that leaves them in a position where they can't actually guarantee access to the imagery, right? So So I'd say there's a little bit of that they have these volumes of very high quality imagery, but they can't always guarantee that they'll be able to provide it. So the licensing terms are a little bit vague. You can still buy the data, but you really can't do anything with it.
Understood.
You dig into the terms of use very deeply. So, I mean, maybe eventually that will be sorted, and you know that imagery will be more accessible to everybody who wants to use it for. But for the moment, it's very much a Google with their arms around their own imagery.
Sure.
Mapillaries is a bit more diverse. They have, I think they passed the 8 billion images. I can't remember off the top of my head, but they had a huge number of images. But the quality can be a bit varied because it's taken, you know,
by people,
with dash cam and it's raining and the windscreen wipers going back and forth, whatever. So Apple have started, and that's not released yet as a commercial product either, as far as we know. But there's plenty more imagery being captured privately by surveillance companies, by surveying companies. So actual construction and engineering surveyors who go out with very high accuracy, they call them mobile mapping units, with IMUs and GPSs, and everything is calibrated and very accurate,
very precise,
and very high resolution imagery. So there's a lot of potential. There's also a company called Evercam. They are monitoring building sites, and they're doing a lot of their, you know, for insurance purposes, for monitoring the use of resources and all that kind of stuff. So it does beg a lot of security questions, you know, and people do get quite nervous when they hear surveillance and when they hear, you know, monitoring and recording and all that kind of stuff. But at the same time, it's a source of data that shouldn't be ignored, because it does contain a huge amount of information, and information is power at the end of the day. So yeah, so it's not going to go away. And the other side of it is it generates huge volumes of data. So you have to be able to process and extract information and then dump the data, really, because you don't want to be sending, you know, we'll melt the core of the planet if we have to send all this information around all the time. So ideally, you process the imagery without anyone ever seeing it, and then dump it and just take the results of it. You know, that's viable from a trust perspective and from an ethics perspective. So you might have seen Ubotica and Intel Movidius have launched their AI in space, which is really exciting. They're using trained neural nets to remove cloud cover from satellite imagery.
Oh wow.
Yeah, so that's the idea in general, is that you will put intelligence at the edge of the network that will, you know, look at the scenes, gather the information, and only give you back what it is you need to know. So, you know, a lot less invasive, a lot less security risk in terms of what you gather about people and what you can see in the world.
That's perfect. So we're running up on time here. So exciting stuff that you're doing, exciting potential and possibilities. Obviously, you'll run up against compliance at some point. You'll run against privacy and security at some point. And you're dealing with data and you're dealing with people. Inevitably, there's a collision. Funny how that ties into the overall theme of what I do around here.
Nice one.
You know, I polished this marketing ahead of time for sure. So in your own words, and, you know, keep it to 30 seconds, as it were, like what if there's one thing that you can impress upon somebody that's coming into this space, you know, regardless of who they are, and they're looking at data, they're looking at the possibilities of technology, what would be one thing that you would relay to them that you've come across in your experience?
The possibilities of data. I suppose knowing what you're going to use it for and who might be impacted by what you're using it for has to be at the core of what you're doing.
Yeah.
So making sure that the data is being used ethically. You know, and there's in the Adapt Center, there's a group who study and report and kind of do the governance on use of data, and they have a tool which they call the ethics canvas, and it's basically when you're setting out your research agenda, you ask all of these questions according to this canvas in order to inform which direction, what data, who the end user is. Who the end user is always going to be the thing that determines what you do and whether you do it properly or not, I think.
Well, I appreciate the context on that, Julie, and it's awesome to get to talk to you. There is a reason why you end up on my list, always. And
Thanks.
I look forward to bringing you on in the future. We got some great folks within the startup community in Ireland that I know Rob Sullivan would be someone I want you to have a conversation with me and him, because he's
Okay,
brilliant.
cool.
He developed AI for self-driving cars, like, things that how things come together. And so it's all about connecting these dots together. But I
That
appreciate
sounds
your
good.
time today, and I got to go run and do another call. So I will let you go on that. Thank you
It's a
so
pleasure
much.
talking to you. Thanks so much.
Always.